in this video we're going to discuss the CISC and RISC difference. So there can be 3-mark question in the difference between CISC and RISC, or maybe more than that. Maybe 5-mark, 4-mark question can also come. So CISC means what? CISC is complex instruction set computer. CISC is a computer architecture in which the processor support a large number of complex instructions. So in CISC full form is what? Complex instruction set computer. So it is called as complex instruction set computer. So here the processor is supporting large number of complex instruction, as the name said. So each instruction here can perform multiple low-level operations such as loading the data from the memory, performing an arithmetic operation, and storing the result back to the memory, all in a single instruction. So here it is say that if you take one instruction from the instruction set and says that one instruction can do all of the thing, that is accessing the loading the data from the memory, performing the arithmetic operation, storing the result back to the memory, all of these things can be done by that one single instruction. So it is like all in a single instruction perform all of these things, right? For example, here if I'm writing add a comma b means this would read a and b directly from the memory, add their result and store the result back. All of these things are happening in one instruction. Such type is known as CISC. So CISC is called as complex instruction set architecture, where it is basically dealing with large number of complex instruction. That means if you take one instruction from that instruction set, that can even access, load the data from the memory, perform the arithmetic operation, store the result, all can be done in one single instruction. That is why it is called as complex. So the main objective of RISC is that it is basically used to reduce the number of instructions in the program and make programming easier by reducing the number of instructions, and reduce the memory usage by writing fewer lines of code. So these are the main objective. It would reduce the number of the program instructions, right? The number of instructions it is there. So that means it becomes easy for us to do programming because the number of instructions in the program is less. Okay, and it can also save memory. Why we are saying that it is saving memory? It reduces the memory usage by writing fewer lines. Since there is fewer lines of code is only there, it reduces the memory usage, right? Because there is only fewer lines of code, so it reduces the memory usage. So here if we see, these are the main objectives here. Now if you see the characteristic, it has a very large instruction. This process may have 100 of instructions, and some instructions are very complex and take many steps to execute. The first thing is that it has a very large instruction set. There are a lot of hundreds of instructions, and one instruction itself, if you take, it would take multiple steps to execute that one single instruction itself. The variable length instruction means one instruction can be 1 byte, another instruction can be 2 byte, another instruction can be more. So the length of the instruction is different for different instructions. So this makes the instruction decoding slow and complex. So because the instructions length is variable, the instruction decoding and all becomes slow as well as complex. Now memory to memory operation means many CISC can access memory directly. Memory to memory operation means in CISC architecture they can access the memory directly. That is why it is called as memory to memory operation. Multiple clock cycle. For a single instruction, it takes multiple clock cycles to complete for a single instruction, because there are one instruction has many instructions in there. That is why one instruction will take several steps. So they would be taking multiple clock cycles. It is a micro-programmed control unit. So it uses a micro-programmed control unit. Now many addressing modes means it supports many ways to access. There can be direct ways, indirect ways, indexed ways. So many addressing modes are basically possible. And pipelining is inefficient here. Here in order to pipeline it is very difficult. Intel x86 family, VAX and Motorola 68000 are the different examples of CISC. So the first you have to learn this characteristic of CISC. Okay, large instruction set. It has a very large, hundreds of instructions are there. Some of them are very complex and requires lot of steps to execute even one instruction set. So large instruction, it is variable length instruction set. One instruction can be 1 byte, the second instruction can be 2 bytes. So since it is variable instruction, it is very difficult for decoding and executing because it is very complex. so the decoding becomes very slow. It has a memory to memory operation, so the memory accessing method is also, there are a lot of addressing methods, so there are many addressing methods here, and it is difficult to pipeline here. Then I told you that many clock cycles are there, then it is micro programmed control unit, and then these are the things which we have told, example of CISC. Okay, and the main objective is to save the memory, programming becomes easier, reduce the number of instructions in the program, that is the main things. Okay, so if I am freshening up the characteristics here, first characteristic is the large instruction set. What do we mean by large instruction set? There are hundreds of, sorry guys, so there are hundreds of instruction here. Since there is hundreds of instruction, there's a large instruction set, there are hundreds of instruction which is present here. Now it has variable length of instruction, all instructions are variable, so decoding becomes slow, execution becomes slow, variable length. Okay, then memory to memory operation means directly they can access the memory, that is why memory to memory. So when we are talking about memory to memory operation, we can also say, 1 minute guys. So you can also say, so when you are talking about memory to memory operation, you can access say that there are many addressing modes. Many addressing modes are there, and multiple clock cycle. There would take multiple clock cycle to execute that. Right? It is micro programmed controlled. Micro program control unit. Fine. Then finally we told pipelining is difficult. Example you have to remember: Intel x86, VAX, and Motorola 6800. Fine. Now RISC. RISC means what? This was complex instruction set computer is CISC. Okay. Now RISC means what? RISC means it is a reduced instruction set computer. Reduced instruction set computer would be the opposite of CISC. That here it uses symbol instructions and it has a fixed length, and many registers are used to improve the speed and efficiency. We told here that its length is fixed. We are using a lot of registers here, and it is symbol instruction. It is not complex instruction. So RISC is a computer architecture. It is designed which has a small set of symbol and fast instruction, and each instruction is designed to execute in a one clock cycle, and only load and store instruction would access the memory. Only one machine instruction per, that is a machine cycle, is defined to be a time it takes to fetch two operands from the register performed. So it has a machine cycle. If we say one machine instruction per machine cycle, per machine cycle only one machine instruction would be there. ARM RISC-V, MIPS, Spark, right? ARM, Spark, MIPS, ARM RISC-V, Spark, MIPS are different examples of this. Here you have to understand that all the opposite things you can have. It has small instruction set, they are very fast. We are using registers here. Symbol instruction set it is used, and fixed length instruction set is used. Fixed length instruction set is used. Only one clock cycle is there. Opposite you will say one machine instruction per machine cycle it would take. So one machine instruction you have, it requires only one machine cycle. That is what it says. No multiple cycle thing is here. So the main objective is to increase the speed. You can do pipelining very easily, and to make the hardware design much more, simplify the hardware design, because here we have used micro program control unit, so hardware becomes very complex. But here we can make the hardware design much more simple. Instead of performing many things in one instruction, it uses many symbol instructions. These are the main objective: to increase the fast, to make it much more faster, to make pipelining much more efficiently. We will be able to do the pipelining and simplify the hardware design. That is, there was micro program unit, that is very complex hardware. So here the hardware design can be simplified. So instead of having one complex instruction, we are having simple instruction to perform a task. So the basic principle of RISC, if you are considering, is only in the load and store we are accessing the memory, and all other operations are done between the registers. So whenever the operations are doing between the registers means it becomes what? Fast. Whenever you are doing the operations between the register, it becomes fast. Only load and store we are taking it from the memory, and it has a fixed length. Since it has fixed length, decoding becomes much more easier, faster, and execution becomes much more easier. Pipelining becomes efficient, and you have large number of registers which can help to increase the speed and reduce the memory access. Now only simple addressing modes are there. Very few addressing modes. Make circuit design. That is hardware control unit. Hardware control unit we are using instead of microprogram control unit. So what happens is that this becomes much more faster and more efficient. And pipelining is easier. So hardware control unit is there. Hardware control unit is used instead of microprogramming. So the complex hard hardware unit becomes fast and more efficient. Understood? And the addressing mode also, if you see here, we can say that there are many addressing mode. Here only one few addressing modes are only there, and we are using registers, so we don't need to access everything every time from the memory. And the fixed size, they are fixed size, okay. And only load and store require memory, others designate. Now here there was microprogram, but it's here hardware unit, and pipelining is much more easier. Fine. So this is the main things that you have to understand here. Fine. Thank you.